2024, the expression x minus 3 is a factor of, alright, so what we can do, plug in x is equal to 3 in each one of them and see if we get a remainder of 0. But sometimes it might be a little bit tedious to open bracket, close bracket, and put the power 4 and so on. Now I've seen two polynomials of degree 4 here, and I always like to try to figure out what's the shortest way and the easiest way to do a question. Now my calculator only can do up to cubics. So I just gonna check and see the two cubics, and I'm gonna see if those two cubics have a root x is equal to 3. So it's just literally plugging in 4 values for the cubics. The first one will be 2, 6, 1, and 3. Minus 3 is a root. I'm looking for 3 to be a root. Next one will be 1, minus 3, minus 5, and 15. X is equal to 3 is a root for part C. Right, it have two other roots, but x is equal to 3 is indeed a root for this, so this here is going to be one of the answers. So this expressed as a single fraction is, so let me do the shortcut, right? Multiply so, multiply so, multiply so. So I'm going to get x squared minus 9 plus 3 into x plus 3 all over x plus 3 into x squared minus 9. So the numerator, believe it or not, we could factorize the numerator. I'm going to get x squared minus 9 is x plus 3 into x minus 3 plus 3 into x plus 3. So I wouldn't factorize, I would just make life a lot easier. Into x plus 3 into x squared minus 9. So the x plus 3 go cancel by the x plus 3 is on top, and I remain with x minus 3 plus 3, which is going to leave me with x alone on top and x squared minus 9 on the denominator. Now while I will be working this, I will be looking at the options, and wherever my working leading to, that is where I will try and force the issue. So you see how the denominators in them, no denominator had, actually the last denominator had the x plus 3 into x squared minus 9, but the numerator didn't have all that bacchanal. And I know when I expand this numerator here, I'm going to get a quadratic, and I don't know if it could be factorized or not. So that is why I would have erred on the side of difference of two squares to cancel it out. The minimum value. So the minimum value could be the y value. Alright, so let me just differentiate and put it equal to 0. 8x minus 8 is equal to 0. X is equal to 1. When x is 1, plug this into here. I'm going to get 4 minus 8 minus 5. And, well, you can't be too sure. Jump on the calculator. 4 minus 8 minus 5 minus 9. If x squared minus 6x plus 13 is, so we had to complete the square, I'm gonna go through my regular, the real true way to complete a square. I'll get x squared minus, give myself some room, yes, x squared minus 6x plus half the coefficient of x, which is half of minus 6, which is minus 3 squared, plus 13, take away 1 into minus 3 squared. So a is 1, so I'm going to get 1 into x minus 3. H is minus 3, and the only one that lines up going to be a. I'm just going to entertain this here, plus this is going to be 13 take away 9, and 13 take away 9 is indeed going to be 4. The roots are, well, I'm going to go on my calculator one time. I'm going to actually calculate the roots. So the roots of this particular 3 minus 7 and 3, they are real and they are different. So they are real and distinct. What values of y simultaneously satisfies the equations y is equal to that and y minus x is equal to, so the two y values. It had no way to cheat the system here. We have to go and solve for y. So when I'm solving for y, I want to eliminate x. So from here, I'm going to rearrange y, take away 1 is equal to x, and plug that into here. So I'm going to get y is equal to y minus 1 squared, take away 3 into y minus 1 plus 4. Oh, gid. Alright, no scene. Let me go through the working. Y is equal to y squared minus 2y plus 1 minus 3y plus 3 plus 4 y squared minus 2y minus 3y is minus 5y. Bring this across, it becomes minus y, so I'll get minus 6y. 1 and 3 is 4 and 4 is 8. Let me solve this on the calculator now. So another quadratic to solve. 1 minus 6 and 8. Solutions are 4 and 2. So the answer for this is D. So the same technique I would have showed you guys before. Put the numerator equal to 0. X is equal to 2/3. And the denominator, x is equal to minus a half. And we're not including minus a half in my solution. I want to say that is the answer one time, because I know I don't have to put x is equal to minus a half as an answer. Alright, so we continue with the working. Multiply the x values, I'm going to get a positive. So the positive x value leads to this. I want to know where it's less than 0. Less than 0 is here. The only answer that given me less than 0 range is going to be the part C. So part C was indeed correct from the set, from the get-go. So again, similar question. We're looking at greater than in this case. So we're looking at here and here. So the only thing that lines up with those solutions is going to be part D. So I'm going to just confirm and solve to show that the critical values are indeed minus 2 and 1/3. So 3, 5, bring the 2 across becomes minus 2. 1/3, minus 2. So far, I don't think any repeat questions. Show yourselves. 4 over root 6 minus 2. Again, a numerical answer. I go in and check and see what 4 over root 6 minus 2 is. 4 divided by open brackets root 6, take away 2, 8.898979. Let's check and see. 2 into root 6 minus 2. No, this is 0.898979. So 2 into root 6 plus 2. 8.898979. So yes, B is the answer. I just go in and check what is root 6 minus 2 and root 6 plus 2. Root 6 plus 2 is 4.49, and root 6 minus 2 will be even less than that, which is that. Alright, so the nth root of 3 multiplied by 27 to the m, that is 3 multiplied by 3 to the 3m, which is 3 to the power 1 plus 3m, and all of that is being raised to the power 1 over n. So it's going to be 3 to the power 1 plus 3m all over n. 3m plus 1 is the same thing, so D is the answer. Log x to base p is 6. Log y to base p is 4. So using laws of logs, there's going to be log x take away log y. which is going to be 6 take away 4, which is going to give me 2. The value of x for which this is equal to 90 is, okay, so for this question, they gave me 4 options. One of the options is correct. For sure. My advice, take the easy ones that you're seeing, like part B, which is 2, part C, which is 44. Take those answers and plug it in for the value of x. And see if you get it. If you end up getting your answer, well, boy, we happy. Alright? If not, well, we're going to have to go and work out what this is, which is not a difficult task. Work out what this is and plug it in for x. So let me try 2 first. So I'm going to get 3 to the power, 2 plus 2 is 4, plus 3 to the power of 2, I get 90. So luckily, B is indeed my answer. Cool? Why is my camera go? Just away? Huh. Let me just check something here. Okay, that's interesting. Alright, so let me just show all you how to use the half and so on. Plugging in 44 up here, real easy. If I wanted to plug in part A on top, right? What I will do, I will work out what log 90 divided by log 3 is. Take away 2. Multiplied by a half. Save this in a particular slot. Save it as an A. And then I'll have 3 to the power of A plus 2. So I'll have 3 to the power, open brackets, A plus 2, close brackets, plus 3 to the power of A is equal to, if I get 90, then A would have been the answer. And I'll do the same method for part D as well, log 10 over log 3. Which of the following is not an arithmetic sequence? Calculator again, you know. So let me work from the right hand number, making my way back, right? So it's going to be, I'll go write it in here instead of showing gestures. This take away this. Then this take away this. Right? I'm going to do that for all of them. 20 take away 16 and then 16 take away 12 and so on. I mean, watching it here, 8 plus 4 plus 4. Well, this is arithmetic. Okay? So I want to know which one is not an AP. So let me check and see, right? Minus 19, take away minus 8. Minus 11. Minus 8, take away 2. Minus 10. So U is not an AP one time. So that means everybody else is an AP, eh? B is an AP, we already see that. 33 take away 39 is minus 6, and 39 take away 45 is minus 6. Good. Minus 13 minus 11 minus negative 11 is minus 2, and minus 11 take away negative 9 is minus 2. Good. So B, C, and D are confirmed APs. A is the confirmed not AP. The sum of the first n terms of a geometric series S sub n is 4 to the power of n plus 1. For the series, the common ratio is 1. The first 3 terms are so by so, and S sub n. So this is the easiest one for me to test. Alright? Are the first 3 terms 3, 12, and 48? Let me check and see. Actually, no, that's not really the first. That's not the easiest thing to test, you know. This is the easiest thing to test, right? So S sub 2n is going to be 4 to the power of 2n take away 1. Is that 2 to the power of 4n take away 1? That's going to be 2 squared to the power of 2n take away 1, which is 2 to the power of 4n take away 1. So 3 is definitely true. So this is true, which means these 3 have the possibility of being true. I'm going to check and see what 1 is. S1 is the sum of the first term, which is going to give me A. S1 go be T1. That's going to be 4 to the power of 1 take away 1, which is going to be 3. That is my first term. S2 is going to be A plus T2, or T1 plus T2. So S sub 2 is going to be 4 squared take away 1, which is going to be 16 minus 1, which is 15. So I have the first term, and I have the sum of the first two terms. So if the first term is 3, and then the sum of the first two terms is 15, then this had to be 12. Cool? Is the common ratio minus 1? Brethren, no. The common ratio going to be, from here, looking like the common ratio is 4. So I know 1 air walking. So since 1 air walking, you can walk, you can walk, you can walk. The only thing left is C. Alright? But let me just test and see if C is really the answer. The only way to see if C is the answer, I have to check and see if the third term is 48. So S3 gonna be T1 plus T2 plus T3. 4 cubed, take away 1. 4 4s are 16 by 4 is 64. 64 take away 1 is 63. So I have the sum of the first two, and the sum of the first 3. When I take them away, if I take away this, I'm going to take away T1 and T2. So 63 take away 15 is indeed 48. So brethren, we have the answer. The expression alright, there's an easy one. We only going up to 5 terms, so make life easy. Just expand on the summation. We're going to get minus 1 to the power 1 multiplied by 3 to the power of 1 plus 1 is 2 plus minus 1 squared 3 cubed plus minus 1 cubed 3 to the power 4 plus minus 1 to the power 4 3 to the power 5 plus minus 1 to the power of 5 3 to the power of 6. I can eliminate the minus 1s and so on, right? So this remains as a minus, so I'm going to start rubbing off the ones that don't matter. This is a positive, so I'm rubbing that off. All the even powers are going to be positive. So on my calculator, I'm going to check it and see, right? That is minus 9 plus 27. Then minus 3 to the power 4 is 81. Plus, well, I'll go add 3 to the power 5, right? I'm going to bother to work it out. And I'm going to take away 3 to the power 6 minus 549. The answer is D. Now, the other way to do this is to go and figure out what the first term is, figure out what the common difference is, and calculate the sum of the first 5 terms. That's another easy way to do this, right? But that involves some of us probably can't really remember the formulas and so on. So just expand on the summation and take your time. The line through the points Q and R is parallel to the line with the equation that the value of H is. Would you all believe in pure maths we have questions like this? In unit 1 we have questions like this. Let's go ahead and get what the gradient of the line is. And this line is parallel to QR. So the gradient of this particular line is going to be, when I send the 2x across, I'm not concerned with the minus 10. Y is minus 2x. Brethren, use my gradient. x1, y1 and x2, y2. The gradient, which is minus 2, is equal to y2 minus y1 over x2 minus x1. 8 take away 2 is 6. So minus 2 into 4 minus h is equal to 6. Divide both sides by minus 2. 4 minus h is minus 3. Move the h, move the minus 3. I get 4 plus 3, which is 7. The coordinates of the center of a circle with equation this. I know the it's supposed to be x minus a squared, which is here. So I know the x coordinate of the center is minus 1. The only one of these that has the x coordinate at the center is this. So let me just entertain the rest of the question. It's supposed to be y minus something. Minus 3. So, sorry, 1. Sorry. 1. My bad. 1 is the x coordinate for my center, and minus 3 is the y coordinate for the center. So, my bad. Part C. It's x minus a into y minus b, where a and b are the center of the circle. The line and the circle intersect at the points. Alright, so this is where, yes, simultaneous equations here are going to be super duper easy to do because we go end up with a quadratic. But I'm just going to show all an alternative way for those of you all who just catch the NN to solve simultaneous equations, but you could substitute values. Well, one of these answers is correct. Alright, so what you could do, you could go ahead and substitute each pair of points into the two equations above. And once you get something that making sense, we're good to go. For example, x is 2, y is 1. If I plug in x is 2 and y is 1 here, I'm going to get 2 plus 1, which is 3. But I want x plus y to be minus 1. So I know a cannot work. What about minus 1 and 2? Minus 1 plus 2 giving me 1. It must work here as well. Minus 1 squared is 1 and 2 squared is 4. So minus 1 and 2, it's working for this equation as well. Let me just check and see if 2 minus 1 working. X is 2, y is minus 1, 2 minus 1, good. And that will also work here. 2 squared is 4, minus 1 squared is 1, 4 plus 1 is 5. So the answer for this is B, by a process of substitution. For those of you all who want to go through the process of simultaneous equations, y is equal to 1 minus x. So I'll go get x squared plus y squared, which is 1 minus x squared is equal to 5. X squared plus 1 minus 2x plus x squared is 5. I'll get 2x squared minus 2x. Bring the 5 across. Minus 4 is 0. Me are gonna bother to divide by 2. Me I want to do nothing too fancy. I just gonna solve this. So the x values are 2, minus 2, and minus 4. So one of the x values is 2. Alright, so this is this x value here, which is 2. And the next x value is minus 1. So it have no other pair of points that gives me 2 and minus 1 as my x values. This is x is minus 2, x is 1, x is minus 2, x is minus 1, and x is 1, x is 2. So that is the other way we could have done it by using the simultaneous equations. So I see an error. All options are correct. Let's test it and see why. The triangle OAB has vertices given by 0, 0, A0, and 0, 4. Given that the angle AOB, alright, so O is 0, 0, A is A0. Let me put it as coordinates, right? 0, 0, A is A0, and B is 0, minus 4. Well, this is a right angle triangle one time. If we draw this on our vector plane, we're going to have 0, 0. A0 is somewhere on the x-axis. 0 minus 4 is somewhere down here. This is OAB. So that's the vector OAB, right? Oops. That the triangle, sorry, OAB. The angle, given that the angle AOB is 90 degrees, which we see in here, A is equal to, A could be any number. A could be down here. I'm still going to get a right angle triangle. Alright, so that's why all options are correct. In order for us to do this question as a dot product, watch what will happen, right? We'll have to dot product OA dotted with OB, and that will be equal to 0, because they say that the angle is pi on 2. If the angle is pi on 2, then the dot product is equal to 0. So from O to A, that's going to be A0. And O to B is going to be 0 minus 4 is equal to 0. When I dot product, I'm going to get 0 plus 0 is equal to 0. And we will get, it is consistent, but it has no solutions for A. Alright? So the only way to do this one here, to see it without doing a dot product, is to draw it. The vector A is given as that. A unit vector parallel to A is, a unit vector has a magnitude of 1. This don't have a magnitude of 1. This don't have a magnitude of 1. These two could have a magnitude of 1. Let's check and see what the magnitude of those two vectors are. Alright, so I'm going to expand out the the vectors. I'll get 5 on 13 and 12 on 13. So it's going to be 5 on 13 squared plus 12 on 13 squared. 1. Remember, I have to square root that, so the answer is C. Square root of 1 is 1. The position vector of the point P relative to an origin O is given as P is 5i plus 2j. And the position vector Q relative to an origin O is minus 4i plus 10j. Which of the following statements is true? P and Q, are they parallel? They are not parallel. So one time, you not true. But I want to know which one of these statements are true. How do I know they are not parallel? These two are not scalar multiples of each other. P and Q are perpendicular. Well, all three here relies on me calculating the angle between P and Q. So might as well dot product them. So P dot Q is equal to 5, 2 dotted with minus 4, 10. I'll get minus 20 plus 20, and I'm going to get 0. So P and Q are perpendicular. If cos 2x is equal to 1 minus 2s squared, then sine x is equal to OGID. Alright, so this is where our identity is going to come into play. And you might be wondering, well, which identity do we use? Once you could get an identity relating cos 2x and sine x, you could big up yourself. We know that how cos 2x is equal to 1 minus 2 sine squared x. Cos 2x, that is 1 minus 2s squared. Bring across the 1. I'll get minus 1 is minus 2 sine squared x. I'm going to get minus 2s squared is equal to minus 2 sine squared x. Divide both sides by minus 2. I'll get s squared is sine squared x. Square root both sides. Sine x is going to just give me s. Nice question. Nice question. The exact value of cosine 5 pi on 12 is, well, brethren, again is a numerical game I'm playing here now. Mode 0, setup 0, 1, radian measure, cos 5 pi on 12. What is that? Cosine of 5 pi on 12. 0.2588. 19045. Nice. I'm gonna check my answers and see which one given by that, right? Root 6 minus root 2. Root 6 take away root 2. And I'm dividing this by 4.2588. A is the answer. Alright, so to just check the others, we can have root 6 plus root 2. Root 6 plus root 2 divided by 4. We again what we want. Then root 6 plus root 2 divided by 2. So I'm just anyway. All I get the picture, right? Aha! A lie. It looked like a repeat question. But the one before that one, that's to calculate the perimeter, I think. If the area of the semicircle is 32 pi, what is the length of the arc connecting the points A and B? Not a bad question. So the area is 32 pi. So the area of this is just pi r squared divided by 2. That's the area. So pi r squared divided by 2 is equal to 32 pi. Well, the pi's cancel. R squared is equal to 32 by 2 is 64. And r is equal to 8. The length of the arc is going to be 2 pi r multiplied by a half, which is just pi r, which is going to just give me 8 pi. Very nice question. Item 25 refers to the following graph. So same thing like what I explained before. One revolution by default, cos x or cos 1x says one revolution is completed every 2 pi radians. Over here, half actually. Yeah, this on one revolution for cosine is going to be a up, a down. That's one revolution for cosine. So over here, right, if I were to continue this and I go again and I go up to 2 pi, 2 revolutions is being completed in this particular scenario in 2 pi radians. Cos 2x. I'll catch that, right? Aha. Again, I could assign values for x. Work out what sine x over 1 minus cos x is, and add it to sine x over 1 plus cos x. And then I'll check and see what 2 sine x is, 2 tan x is, tan squared x is, and 2 over sine x is. And see which one gives me the same numerical value. And the value of x that you pick, it could be anything. Anything, but make sure it's well weighed. But I'm going to go through the trigonometric proof approach for this particular question. So cross multiply here, and then I'll multiply the denominators by each other. So I'll get sine x into 1 plus cos x plus sine x into 1 minus cos x. And the denominator becomes a difference of 2 squares. 1 minus cos x multiplied by 1 plus cos x. That is a minus b into a plus b, which is a squared minus b squared. So that's going to be 1 minus cos squared x. Now 1 minus cos squared x is sine squared x. My numerator going to be sine x plus sine x cos x, and follow sine x plus sine x cos x plus sine x minus sine x cos x. So the sine x cos x goes away, and on the numerator I end up with 2 sine x. On the denominator I end up with sine squared x. U cancel with 1 of u, and I get 2 over sine x. Pay attention to this. This is one of the common repeat questions as well. If sine of 90 minus x is cos x, now this is an identity all by itself. This is true for all values of x. Alright? If we were to use the compound angle formula, let me see what we could get. These kind of things here, stems on a compound angle formula, right? We want to know what the value of x is. So no scene. So we end up with sine 90 cos x minus cos 90, sine x is equal to cos x. Sine of 90 gives me 1. Cosine of 90 gives me 0. So this goes away. So I'll get 1 cos x is equal to cos x. If the same thing is equal to the same thing, then for all values of x, this will be true. Cos 35 is cos 35, cos 45, and so on. Cool? Aha! Check thing here. Me going on hot my head. I have my calculator. Sine 50. Oh, change back your calculator in radians, please. I'm in degrees. Sine 50, cosine 40, take away cosine 50, sine 40. Now I know what identity it is, but this is the easier way for everybody. 0.173648177, sine 10 as well. Yeah, man. Sine 10 is good. Right? Now this is sine cos, cosine. That's going to be a sine identity. It's sine of A minus B, which is going to be sine of 50 minus 40, which is sine of 10. The size of the angle x measured in radians, so that is 160, that is 20 degrees. So 20 degrees in radians, I had to multiply by pi on 180, bram, 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 pi on 9. So again, I have a compound angle formula here. I can go ahead and plug in a value for x in this scenario, or I can expand out both of them. Well, I'm going to expand out both of them because the plug in a value for x day, I mean, it's not that bad, you know? But let me go and plug in the value for x, yes? Let me let x be 1.2332. I just make up. So I'm going to save that. 1.2332. Store that in A. Nice. Sine of pi on 2. Take away A. Plus cosine of A plus pi on 2. Now I'm supposed to change my calculator in radians. Change it in radians. I get a negative 0.6123333478. Where's tan pi? Not that. Sine pi minus cos pi. Sine A minus cos A. Oops. Sorry. Now I want a negative, It's the same number, but I want a negative. So what about cos A minus sine A? Yeah. C is the answer. Now, excuse me. If I wanted to do the long working for this, I will go and expand the compound angle for this, expand the compound angle for this, and see what I get. All right. The first derivative, I'm going to get 5 minus x to the power of a half multiplied by minus 1. 5 minus x to the minus a half. So I get in minus a half over the root of 5 minus x. The 2 could go in the denominator to get minus 1 over 2. D is the answer. At the 10-meter stopping point on a runway, an airplane is stationary before takeoff. If the airplane travels 120 meters from this point in 4 seconds, what is the speed at the point of takeoff? So that 10 meters in the beginning, there's a ghost 10 meters. Because soldier boy take off yet. Alright? Speed is equal to distance over time. Distance is 120. over 4 to t meters per second. Make sure the unit is meters and seconds. Any question? It is. The gradient function of a curve, so they want us to differentiate. When I differentiate sine, it changes to cosine. And I must multiply by the differential of the angle. 2 2s are 4x. So 4x costs 2x squared plus 1 is the answer. The point lies on the curve. The gradient of the tangent at the point P. So we have to use the quotient rule here. Again, knowing how to use the quotient rule mentally without statements is a good skill you can develop. This is U, this is V. V du dx minus U dv dx all over V squared, that's dy dx, right? They say when x is 1, well, the point P lies on the curve, so when x is 1, I can go ahead and actually plug in x is 1 here one time before I simplify, but let me simplify first, right? Simplifying, I'm going to get 6x minus 3, take away 3 2s are 6x, plus 4 all over 2x minus 1 squared. 6x minus 6x goes away, minus 3 plus 1 is, and plus 4 is 1. So simplifying it worked out a lot better in my favor. Plugging in x is equal to 1, I'm going to get 2 into 1 minus 1, which is 1. 1 squared is 1. 1 divided by 1 is 1. Number 35. The curve has equation y is equal to f of x. C has a stationary point at minus 1, 2. If the second derivative is that, then minus 1, 2 is, just plug in the x value inside of the second derivative. I'm going to get 6 over minus 1 to the power 4 plus 2. I'm not concerned with the number I get. I'm concerned with the type of number, if it's positive or negative. U is a positive. So this is going to be, it's equal to 8, and that's greater than 0. Greater than 0 means we are positive, which means we are smiling, which means we have a minimum point. 36 refers to the following graphs, which shows the journey of a boy where time is given in seconds and velocity in meters per second. Alright, during the journey, there's a stage where the boy accelerates. The value of the acceleration is, this is where Soldier Boy accelerates here, and that is vertical distance, which is going to be, what is this distance here? 10 over the horizontal interval, which is going to be 4. 10 over 4 is 2.5 meters per second squared. So B is the answer. If C is a constant, then the integral of this is, so add 1 to the power over 4. And we have to put the differential of the brackets on the denominator as a multiplication. So 8 is on the denominator. So 2x minus 5 to the power 4 all over 8. The answer is C. So if the integral between 4 and 1 of f of x dx is 6. Alright, so laws of integration, this is 4, the integral between 4 and 1 f of x dx. And then I had to add 5 to that. So this is 4 by 6 plus 5. 24 plus 5 is 29. Please don't make the mistake and integrate 5 and put it between the limits 4 and 1, please. You're not going to have a good time. Aha, there's a repeat lookinish question. Like I said, every time I'm integrating trigs, I always like to say if y is cos x, if y is cos x, the differential is going to be minus sine x. So when I'm integrating sine, that changes to negative cosine. So I'm integrating sine, so that's going to be minus cos x plus 2 sine x. So 2 sine x minus cos x. A is just a variation of my answer. The region R is enclosed by the x-axis, the curve, and the lines x is 0 and x is 1. The area of R is, okay, good. We meet all the requirements to write down the integral sign, 1 and 0, of, I'm not going to put minus x squared plus 2. I'm going to put 2 minus x squared dx. 2x minus x cubed over 3 between 1 and 0. I know the lower limit when I plug it in will be 0, so I'm just going to plug in the upper limit, which is going to be 2 by 1, which is 2. 2 take away 1/3 is 1 and 2/3. Can't be too sure. 1 and 2/3, 1 3 is 3, 4 5 1 3. $108 cards in a deck of Uno. Of these, 4 are wild. 4 are wild draw 4. And each of the 4 colors is represented by the 25 cards. If a player needs to select one card, what is the probability of not drawing a wild draw 4? How much wild draw 4 there are? It are 4 wild draw 4. So the probability of not selecting it is 1 take away the probability of selecting it. So if it have 4 wild draw 4, the probability of picking that is 4 over 108. So 108 over 108 take away 4 over 108 is 104 over 108. And again, as a man can't be too sure. I know for sure it can't be this and it can't be this, because them denominators is over 108. It can't be this, that too small. It had to be A. But again, I can't be too sure. I will check over 1 plus 1 on my calculator if I have to. 104 over 108 is 26 over 27. Forget the key. Right? Let me just 104 over 108. 26 on 27. One advantage of using a box and whisker plot is the variance can be identified. We can see variance on a box and whisker. All data values can be identified. Nope. The mean value can, nope. The spread of the distribution can. So D is the answer. If I get 42 wrong, something wrong with all you. 43 and 44 refers to this. There are 120 students in a school's music club. The Venn diagram shows the probabilities that a randomly selected student plays the piano, guitar, and then it have men who play piano and guitar. What is the value of x? Oh, easy. So add up each. No. The value of x is looking for a probability, right? So the 120, they just give me that information just for style. So this plus this plus this, take it away from 1 will give me the answer. So 1 take away 0.4 plus 0.35 plus 0.15, 0.1. What is the probability of n given that g? That's the probability of n intersect g divided by the probability of g. N intersect g is 0.35. The probability of g is this here. It's not 0.15. 0.15 is g only. So 0.15 plus 0.35, 0.5. 0.35 divided by 0.5, 0.7. Alright, the tree diagram above shows the probabilities of event A and B occurring. Based on the diagram, the value of the probability of A, given that B has already occurred, is 4/5. The probability of A, given that B has occurred, is just 4/5. Okay. Alright, and that is it for 2024.